And we are live. Normally speaking, our audience is with us as well. We just heard, how many people were there? Like 12 or something like that. Hello, people on the other side of the screen. I'm here joined by my colleagues from Data Minded. My name is Oliver. And today we're going to be talking about how to future-proof your data engineering career. Can everybody hear me very well? Because I'm trying to see if we have some interaction there, if there's any kind of audio issue or maybe a video issue that we need to know about. Wonderful. Thank you very much, people. Just wanted to mention already before we start fully with the discussions, you will find at the top of this, on the right side, at least for me, that there is a poll in the interaction tab. So you've got like 5 tabs apparently, and one of them is a poll that you will see. I can start. You might not see it yet. I will start it right now. You will have about a minute and a half to answer the question, what do you expect for this webinar? That part should be present right now. You can start answering what do you expect from this webinar. Perfect. I see some answers coming in. That's a good sign that things are working as expected. And once that one is done, I'll be talking, well, also activate one more button, but it's slightly less important for our webinar. It's about your background. So let's give it a little bit of time. I don't know if people can see this, probably they can't. On the other side, what do I see here on our end? Most of the people right now, about 80%, wants to learn more about new trends in data engineering. Then the next big piece is finding the best learning resources, and finding out how to become a data engineer is definitely topic number 3. There are a few other suggestions coming in, and I hope that we will see that popping up in the chat. All right, yeah, good research to keep up with the technology is coming from Ronnie. Thank you very much. Okay, so far, the answers are not so much of a surprise to us. We'll try to meet your demands. I'm going to stop that poll right now. Perfect, I've got it. I'll put it later on the slide deck. So for the people who are interested in the slides, I'm going to show you a few, not all of them at the moment, but a few to guide us in. I'll try to extract the answers that we have here in the poll and put them on the slide before you get finally the email in which also this webinar, this slide deck will be present. Now, let's talk a little bit about the people we have with us. First of all, me, Oliver Willekens. I'm from Data Minded. We're all from Data Minded. Now, I've been with Data Minded probably the longest, if you're not counting the C-level management in there. I've been a senior data engineer ever since, well, not senior since the beginning. I started as a junior, definitely. The nice thing about the many years I've spent here is that I have seen many different technologies, many different teams, and many different issues. That's why I believe I can pitch in this conversation and give you a bit of a clue, like how can you make sure that you are a good data engineer? Now, I'm joined here by Jelena, who is one of my colleagues and who is also one of the people who frequently visits She's a teacher at the summer and the winter schools. We have 2 weeks every year in which we teach people about some core technologies that every data engineer should know. Jelena, you want to tell the audience a little bit more about yourself?
Yeah, hi everybody. So I'm a physicist by background. I spent around 13 years in academia doing very interdisciplinary research, and I like to say I was a data scientist before data science existed as a word. But after 13 years of academia, I decided that's not for me anymore, and I started looking for a job. And it's been almost 3 years now that I work for Data Minded as a data engineer. And was also as a data scientist. And I'm also, I've been teaching since the beginning, I think, in our academy. And I was always passionate about teaching. I organized a lot of events about science communication. And at the moment, I'm organizing Data Beers Brussels. So if you don't know that, come join us. And my passion in teaching was one of the reasons why I actually joined Data Minded, because there was academy, so I could continue teaching people, and I also think that teaching is the best way to learn yourself.
All right, thank you very much, Jelena. Another person who is here is Cedric, probably maybe one of the younger people in our team at Data Minded. but that's only because of the amount of time you've spent with us, not because you don't have the experience. You come from a different client as well. Well, client, a different company, in fact. Want to tell the audience a bit more about yourself?
Yes. Well, actually, in fact, the company I used to work for was also a client of Data Minded. I have a computer science background, and I started working as a data engineer for Selligent, which is a marketing cloud automation company. And interestingly enough, through the academy, I got to know about Data Minded. I was very impressed by the quality of the courses, and I liked the teachers a lot. And actually, myself, I also had a thing for teaching. I always had an interest for it, so I decided to give consultancy and also the company Data Minded a shot. So fast forward more than a year later, and when working for a client Luminous, working on a prediction model for forecasting energy production and selling of energy. And now I'm working on pipelines that calculate commissions for sales partners for Luminous.
All right.
So yeah, you can say a lot of broad experiences. Many different things have been touched. I've worked both as an in-house data engineer back in my previous company, and now also as a consultant. So in those years, I've gained some experience. That's true.
Nice. One of the things, Cedric, what I really like about you being present here is that neither Jelena nor me, we actually have a computer science degree. We don't, something more in physics or some engineering related stuff, but we're not computer scientists. We just kind of rolled into the field because, for a lack of better options, I would say. No, definitely. Data engineering is one of the, probably it attracts many people from different backgrounds. I know many physicists have moved into this field, and it's probably because it's fun. It's a good, rewarding job as well. And there are just a lot of puzzles to tackle. I think that is something that many people in this business find attractive. Now, Jelena and Cedric, one of the things that we all have in common is the winter school, the summer school. You're teachers there as well. For the people who don't know, we've been doing that for like 7 editions already, maybe 8 if I need to calculate it again. But over those editions, our format hasn't changed all that much. We basically keep to a couple of core technologies that we really believe everyone should know. And then there's like a big capstone exercise. And the fact that this hasn't changed all that much, our format is somewhat contrary to the notion that people say the world is in constant motion. Our field in data engineering is constantly changing. There are new technologies popping up like on a daily basis. And these things don't seem to rhyme. Why do we stay stuck with a core set and all of the new things that are coming up? Jelena, do you want to give maybe your opinion on this?
Yeah, well, I would disagree that we didn't change it. We always have a discussion and we always adapt to things which need to adapt. But I think the main reason is that what we are trying to teach people here is a way of thinking. We try to make people understand what is data engineering about. We try to make them learn, teach them how to learn, how to quickly find resources, how to Google, nowadays how to use ChatGPT, how to easily find documentation. And these are actually the most important skills. We all know once you know one programming language, you're going to learn another programming language very easily. So the same goes with different technologies. Once you know one cloud, it's easy to learn other clouds. Once you know one database, it's easy to learn another database. So it's not super, we do try to have in our courses the most popular tools so that people are kind of most widely used, but it's more important to learn the basic principles behind this tool than to learn the tool themselves.
Yeah. That's actually nicely summarized. I'm gonna jump ahead in a few slides. Give me a second here. Let's not start this. Thank you. Ooh, yeah. Couple of years ago, Chris, the CEO of our company, and me, we sat together and we discussed 6 skills that every data engineer needs. Fast forward, if you didn't see the talk, basically it's all about this. There are a few things that we really believe like you should get the concepts of, and here, well, many of these things are coming back in those schools, but it's like Jelena says, you need to know something. Like in general purpose programming language, if you know one, you will know the others. So that's why we say like, yeah, you should know one of these things. SQL is in there as a specific case, really, because we believe that people, it's the lingua franca between the data scientists, the data engineers, and the analysts. If you speak SQL, everybody can get along. So you should know that one. But we have found that these are basically the topics that people need to know quite well. Maybe Apache Spark is a bit outdated. Well, not the technology, it's not outdated, but having that on the slide was on that video that I just showed is maybe a little bit pushing it too much into one direction. We still see it coming up a lot in interviews and so on. So it's good to know something about it, but focusing more on the concept behind it, it's about learning what is distributed programming. How can different machines talk to one another? Spark is a good way to do so, but it's not the only one. There are definitely other technologies as well, like Flink is also a nice one, definitely for streaming. For the people who are just getting into the field, at the end of that talk, we basically give you a sort of a roadmap to see, like, hey, how can you really become good at data engineering? And when I revised the slides, it's like, that is still valid today. If you really want to get into this sector, I would try to go this way. I now have that hindsight. For me, it's easy. I did not start with learning SQL. I learned that after I learned Python, but it gives people a bit of a guideline. Now, I'm going to stop the slide because I don't need them here. We'll send the slides to you afterwards during the thank you notes. Cedric, your time as a teacher in our winter school, you immediately had to focus on one of those technologies, and it just happens to be Spark in this case. Now, as I remember, you were a little bit afraid because you were saying that you were not that comfortable with it. However, you have been learning about Spark a lot in one of your client engagements right now, and to be honest, you've got this, right? You mastered this. How would you say that you tried to learn about Spark? What can the people in our audience learn about you as well? How can they learn technologies, not just Spark itself, but how can they master it?
Well, when it comes to learning Spark, it really boils down to what Nathan, a former colleague of ours, has told me about. He said, you should never really have to worry about a programming language. But if you're going to spend 8 hours a day working with it, you are going to get better at it as long as you just keep trying to get better at it. So I think a lot of becoming a good just developer in general, or even just an engineer, and I'm pretty sure it also applies to other fields, is to just not be satisfied too quickly. Continuously looking at your code and asking yourself, what can I do better? After a while, you will notice that maybe you, as a person, don't criticize your code that much anymore, but then let other people who are more experienced or who have just different experiences compared to yours look at your code, let them give you feedback so you can grow from that. Apart from that, if you want to learn any other technology, I think the best thing you can do is just to have fun with it. Try to play around with it. There's certain websites you have like Code Fights or like HackerRank, where you can literally choose a programming language and do all kinds of different things like code golfing or other algorithmic problems that you need to solve. And I think they're a good way to learn the basic syntax of these languages that you want to know.
Maybe relevant at this time is advent of code. It's right now it's the advent season, so people who want to participate, it's a competition. Each day you get like a small new challenge. It becomes gradually more complex, but this is a good way for you to practice your skill. So practice makes perfect, right?
Yes, absolutely. I think that's actually a great suggestion. That's also a perfect example of what you could do to improve your code. But then also, if you're into that, you can also have your pet little projects. I think it's not always as convenient, like, for example, for PySpark pipelines, because it's so specifically geared towards data engineering. You might not necessarily have access to data that big that it warrants using something like PySpark. But especially if you want to learn other languages, for example, Python, and you want to learn how to make some REST API or something, nothing is stopping you from just making your own little website and giving it whatever backend that you want. I also know of engineers who, whenever they have to start with a new project, think about a technology they always wanted to learn, and if it's sort of a good fit, they can start implementing it using that. That's not maybe always the best thing to do, but I do know that these people have learned a lot from that.
Jelena, I believe this resonates with you as well, right? If you want to get good at it, you work with it, you try to improve your knowledge on the job.
Yeah, definitely learning on the job is the best. But I know some of you in the audience probably still don't have a job, and you're wondering, how do I get there to actually be able to have a job where I can learn? And I would add to the suggestion that Cedric made. I think those are all good suggestions. But what I think should be added to this, write bigger codes, like bigger projects, because once solving little things, it's a good practice. But once you start working, you will need to develop big code. You will have to work with other people. You will have to learn how to write understandable code. And this is what makes difference between somebody who knows a lot of little tricks and somebody who is good data engineer on the job, who is actually delivering the value to the business. Because this is what our job at the end is, deliver the value to the business.
So you would say that this may be one of those essential skills, right? How can you make sure that for larger projects, which most data engineering projects are, you are trying to write good code, and good code is a bit of a subjective term. Everybody has different notions about what is good. There is a certain feeling about it, and it also depends on the team. But if you can somehow make sure that other teammates can pitch in, or you can leave and there's something Cedric you also mentioned, you can leave the task for somebody else to start implementing. Being able to contribute or allowing other people to contribute to a code base would be one of those essential skills, right?
Yeah. So like to mention one thing, like there are some things which are subjective about the code, but some things are objective. First, the code needs to work, okay? So one of the essential skills is debugging your code. And when it comes to data engineering, that means making code which works on your data. And we know the data is not perfect, it's far from perfect. And unlike software engineering, data engineering has this other components, which is data. So your code needs to work on data, and you need to practice how to find good samples of your data, which is going to give you as quick as possible notion, is your code working? And if it's not working, why it's not working? So this is the first most important skill. Once you have the code which is working, then you can have a code which is optimized. Okay, then you make it work, make it fast. This is important to know how to, if you're working in PySpark, it's very important to know what is behind the scene in PySpark, how the PySpark works. For some other things, it's not as important. It's also like for some of you who maybe are coming from C++ background, I know like this was my language for many years in the past. A lot of the intuition I know from C++ is not applied to PySpark, because PySpark already resolve all those things behind the scene, and it's no need to optimize those things. So understand the differences between different coding languages and what kind of optimization makes sense, what optimization doesn't make sense. So once you have a code which is running in reasonable time, then you want to have a code which is simple, easy to understand, and which other people can easily understand. And then this is making you valuable part of the team, because if somebody needs to take over, they know that your code is going to work, that it's going to work fast, and they're going to be able to understand it.
Yeah. So it's actually it's a team collaboration skill, right? How well can you make sure that you work with people in the team, for one? But if you want to like future-proof and really go far, then it's more than just the team that you need to take care of, right? You also need to talk to the business stakeholders. Cedric, that's something, in my opinion, you do very well. You want to give a bit more insights in that?
Well, the difficulty when you're a developer is explaining the problems that you have to people who are not developers. So you have to also actually take that into account. You have to try to imagine what they really want to know. Often any business-related person doesn't really care about, a unit test that you've written or a couple of milliseconds that you've been optimized. They just want to get their work done. So and also actually within a certain time frame, because they usually have deadlines, they have promises that they've made to their stakeholders as well. So you always need to try to translate whatever message that you have into something that they can use to then also communicate to their stakeholders. And that is difficult because it means abstracting problems. It means also still giving enough detail that people can understand what you're doing, and you're not just trying to make everything very opaque, or what is it, like vague, fuzzy, because then it just sounds as if you're trying to leave them in the darkness, as if you don't really want to show them what's really going on. So it's kind of a balancing act between, on the one hand, trying to say as much as you can without overloading them with technical information they're just gonna fall asleep from, and actually still thinking about what is relevant to know, what might impact the planning, or what might interest the stakeholders of your stakeholders.
Yeah.
So I think it's always just a matter of seeing the bigger picture and abstracting your technical details.
Yeah, that's actually a good one. When you are indeed down in the fields and you're working with a piece of code and it's bugging you, you are really, really down, and you need some focus time probably to get to the bottom of things. From time to time, make that actually quite frequent, especially if you want to grow beyond just the junior levels. You need to be able to zoom out and look at the bigger pictures, reason about that with the team as well as with this business stakeholders. After all, they're the ones paying for the project. It's for you a way to learn some new technologies. You might introduce a few things, but always keep the client in mind. And your business stakeholder, your champion, is your client at that moment, even if you're not in a consultancy. Yeah.
If I can add to that, I know when I started working and Chris told me, technology is easy, people are difficult. And I was like, haha, I'm going back to learn this AWS, if you don't mind, but the longer I work, the longer I see how true this is, actually, if you want to be a good data engineer, it's important to know your technology, but it's really as equally important to know how to communicate to business holders, how to deliver, also to understand that done is better than perfect. That's sometimes you just need to deliver something, and might not be as perfect as you want, but it's going to be good enough for business. And it's important to learn this kind of things.
True. These are things that are not that easy to learn, right? I mean, when people say like you need to learn a technology, it's typically fairly easy. You go online, you Google for it, you find a course, maybe you can follow a YouTube video or something like that. Personally, I think YouTube videos don't always work very well to learn something very much in depth. It's a good introduction to things, but if you want to learn something in depth, get your hands dirty, start writing stuff. That works pretty well for the technical parts, but for these like the more soft skills and learning how to work with a team, how to do good storytelling, we don't really have online material for that as readily available. I'm not saying it's not out there, it's definitely out there, but I've looked for it for myself, it's not as easy. Jelena, do you have some advice there? How would people be able to make better stories?
I think actually there's a lot of material. So I think it's maybe usually outside of our scope. So you might not going to find it at the same place where you find your technology, but there is a lot of material. Materials like how to give you a good presentation, how to be a good speaker, how to learn with the business. There are a lot of companies which are actually specialized in teaching you how to manage business. McKinsey has a lot of material, for example. They're really experts in that, like how to present things to business, how to develop basically soft skills. So yeah, you can definitely watch those videos, but practice, the practice is there. Also, I think sometimes when you watch these videos, and also, I was giving a lot of talk, how to give a talk, and what I would always explain people, like, hey, everything I tell you now, it's just like common sense, but somehow it really helps when somebody tells you this, it's none of this advice is surprising, but hearing it from somebody and making you think about these things while you're doing it really helps and really makes you better communicator and a better person. But it's also, I think, feedback is very important. Every time you're in this situation, just ask people from your team who were there, hey, was this good? Was this understandable? Is there something you would do different? and then try to think about that and improve it for the next time.
No. I like it. Coming back to the practice makes perfect theme there. I am noticing this myself, that you are a good speaker. One of the things that you participate in, which is kind of like extracurricular, is the Databeers events. You are a speaker there, you're a host even.
Yeah.
This would be a way for our audience or people who are interested in how do I work on these less technical skills. It's just to go out there and set yourself behind something you want to support, like a goal, something like you wanted to become one of these hosts. You're organizing this on a regular basis. It teaches you a lot of things about organization. How do I make sure the other co-organizers, how we get along? You all have kids, maybe you need to figure this out. And how do we get always a nice lineup of the people there? So it contributes to you thinking on a higher level terms, and you're not down in the ruts in the field and then figuring things out. This would be one way.
Yeah, this is one way. Also, I think these events like Databeers, and there are more of them, are good opportunity. I would advise anybody who wants to enter the field, come to Databeers or similar events. This is a very good way to just hear some interesting stories, hear some future trends, meet other people, and have discussions about technology or whatever you want over a beer. And you will it's a good way to kind of keep up to date and to challenge yourself. I think also our event is quite diverse, so we always try to make it like that. So we have people who are very hardcore data engineers, but then we have scientists working on art and archaeology, all this is data science. And I think if you want to work in this field, it's good that you have idea of all of this. So just to have like a big picture. Because you're never, what you do is never just this little thing in front of you. Everything has a big impact somewhere on company, on a business. And it's important to have like bigger picture of what's going on.
So you would recommend to participate in conferences and meetups where people discuss new technologies or some problems to help you become aware of what is out there, what are the new trends. And we were noticing it here in the poll. What are some of the new trends in data engineering? I've personally been quite astonished by how fast the world was taken by the world that we see has been taken by DuckDB, for example. But then I'm noticing how many meetups there are on that topic. And if you really want to learn something, it's very easy to just go there, listen to some keynotes. Eventually, you might want to experience, like play around with it, which is something that Cedric has mentioned here. This is a good way for you to learn, right? So there are ample opportunities to learn about new technologies. It's just a matter of making sure you get the time for that. And I think for businesses, like the leaders, maybe there are a few business leaders here in the audience, don't forget to invest time in the learning opportunities of your team. If you're all the time down in the let's get things done, well, if you're not paying any kind of attention to the team, that they might learn a few new tricks. If they make the same mistakes over and over, you're kind of to blame for yourself, right? If there are people who are not managers, talk to your manager. Make sure there's a budget for you available that allows you to learn, right? There are conferences, PyCon, very popular. If you want to learn more about Python, DuckDB, any kind of SQL things, stuff you can learn. But make sure that you pitch it with a story. And then we come again to that one thing about transferable skills. You need to convince your stakeholder. How do you get to that point? I'm not going to pay the buck myself. I have the money, of course, but you want your boss to pay for this. So make sure the budget is there. Try to convince them what is in there for them. It's a negotiation skill, right? You're saying, hey, I believe I can do better because right now, maybe on my team, I'm the most senior here, but I feel that maybe I need something more. What can you do? Subscribe for a conference, subscribe for a dedicated course. And then you will probably get the benefits from that. The boss might get the benefits from that as well. So see if you can somehow pitch that, do a little bit of negotiation there. Cedric, coming back to the new technologies that are coming up and so on. For 2024 and beyond, we're at the eve, it's December already. Do you believe that there are many new technologies that people will need to know about in data engineering?
It kind of depends also where you are exactly. If you are going to build something from scratch, then I guess there are a couple of new technologies you could maybe try. I see Snowflake emerging right now pretty hard. It's already been emerging for quite some time, but now also at our company we see that people are adapting it more and more. And we also see, like, for example, DBT, which is also very much emerging already for a while, is now getting pretty good adapters that can work with Snowflake databases. But apart from that, I think many of the things that we teach at the academy are still very relevant. So stuff like infrastructure as code. I'm thinking about Terraform, or maybe something else like, I don't know, Crossplane, or perhaps even CloudFormation. These are technologies that will definitely come up. I think it's always relevant to just stay up to date with new cloud services. So the different cloud platforms, they come up with new services quite often. And it might always be interesting to keep up to date with that, because some of these services might benefit you. Something that you've built yourself, you might be able to just replace with a service. And that's already a lot of maintenance work that you can save yourself on. I do think you should always be a little bit careful with those things, though, because we have seen services that were not always a drop-in replacement for something that has been built for a custom use case.
Yeah.
But I think also just a lot of technologies will stay the same. Like, we're always going to have to probably work with Git, or always. I never say always, but I don't see that changing immediately. I think Bash is
more generally version control, right? I mean, it has shown its benefits for teams that are distributed. That is definitely one of the essential skills. I would agree with you on that one.
Yeah, exactly. And what I do also notice is just the continuation of abstraction. So just like PySpark is already an abstraction on, if I'm not mistaken, Hadoop, and also their resilient data sets. And
resilient data sets is that core. True.
We could roughly say that, and that maybe in itself was already an abstraction on like some kind of C++ library that was coordinating a cluster. We can now even see that regular SQL code can also be run on similar clusters. Like, in the end, if I'm not mistaken, I think even databases like Snowflake do that already.
Exactly,
Yeah, and the great thing is that many business analysts who are somewhere in the cross-section between very technical and still business related, they can speak SQL. So I think that is going to be very interesting for also data engineers to take into account when they build new systems. They can make something that can ideally even be managed by the same people that are giving them the business requirements. These analysts are often going to do that.
In a way, you are saying that for the future, even though new technologies, new products actually are coming up, the core things are going to stay the same. People who know SQL will be able to write it. The problems underneath, like how do I do this at scale with Snowflake, for example, and it indeed does it in a distributed fashion without you even realizing this. Spark is actually the same as well, right? I can write Spark on a single node as well as on a cluster. I don't care. It abstracts these things. And we can expect these kinds of niceties from future products as well. Otherwise, people are going to drop it immediately and say, like, no, we want to have this abstraction. We don't want to go that low into the code anymore. So most of the things are going to stay the same. Does it then mean that our business is, if you've been in the data engineering business for many years, that, it's just business as usual, Jelena?
No, I don't think it's business as usual. Not many people believe me, but I'm the oldest person in Data Minded, so I've been around since really long time. I coded for decades before Jupyter Notebook showed up. Over the time, we are getting more and more tools, which makes our life easier. And definitely, yes, it's super convenient now that you can just write SQL in Snowflake and it will abstract everything happening behind and you don't even have to think about it. It's also true that you can use PySpark in a similar way. But if you want to use PySpark and to extend Snowflake to the optimum, it's good for you to understand a bit what's happening behind. So good understanding of distributing computer, it's still going to be the thing which will distinguish okay data engineer from really excellent data engineer. The basics definitely are something which is very important. Git, Bash, SQL. So SQL, yeah, been around for 50 years, not going anywhere. It's with the new engines, which are making it super fast and optimal. It's just going to stay, and it's going to be very, very important. So knowing how to write SQL is very, very good. If you are a data analyst who already very, very good with SQL, I would definitely recommend learning dbt, because dbt will make it possible for you to use SQL as a software engineer with Git, with tests, with different production environments, so production, test. It also has some extra, makes documentation out of the box. So dbt is definitely something which people should learn, especially if your background is a data analyst and you're already very good with SQL. This is going to elevate you further. But one thing I wanted to add, like there is a lot of technologies there are that can help you and they can make your life easier. But also you should be careful how to use it, because sometimes if you pick different technology to solve each little piece of your problem and you put that together, you can make a monster which is very difficult to maintain afterwards. So sometimes it's better to custom made some parts. If you have to put way too many technologies together, then think about how maintainable this is going to be in the future. And sometimes it's worth to just design something yourself, because that's going to be easier to maintain. Of course, this is not always the case, because advantage of using a technology and building something yourself, using outside tool, it's going to be maintained. And what you build yourself, you have to maintain yourself. So
True.
there is a balance there you need to think about.
It actually also brings me immediately to the question on the software development lifecycle, and that's maybe more for Cedric, because you're the computer scientist from the three of us. Many of the technologies that people can learn about in data engineering lead you closer to being able to work on a specific problem. But at the end, you know nothing until you deploy to production. So it's all about making sure all of the components click together and you build it, you run it, it gets into production. Do you believe that the software development lifecycle is something that data engineers don't see as much about because they are mostly writing pipeline code, Cedric, or is that something that they should know more about?
Yeah, I think it is definitely something they should know more about. There's definitely data engineers that do know it, but it kind of depends on where they came from, because you have software engineers that turned into data engineers at a later point in their careers, and these are usually the people that actually already do it just out of instinct. They will try to create an automated CI/CD pipeline. They will write some kind of tests, and they will implement those tests also in the pipeline, and they will find it very important to deploy to production regularly. But there's also people who come from more like a business analyst background, or maybe more like a science background, be it mathematics or statistics, more like the data science profiles that start doing data engineering. And I think it's very easy for them to just get a little bit too focused on getting things done. And getting things done works up to a point, but then there's a point where your project is going to become that big that you really do want to automate some stuff. You don't want to constantly manually deploy your pipelines. You don't want to start maybe even manually running notebooks to have calculations. You want to automate all of that. And I think that's where the software development lifecycle really starts to come in, where you do want to start maturing your development pipeline, just like a general cycle of it. So at that point, yes.
There are definitely some products out there that go a long way in this sense, right? I mean, many people will know about Databricks, and it has not that long ago has, for example, also integrated a bit of Git workflow to make sure that people can more easily get their code that they might have developed somewhere immediately running in production, the Databricks clusters. At Data Minded, we have a similar project. It's called Conveyor. It's very easy. You type something up, and all of a sudden you immediately get it running in production. Moving it from development to test is also quite easy. But yeah, bringing this entire notion of an idea that you're trying to quickly write some pipeline for, and then making sure it runs on a daily basis, oftentimes it's about batch jobs. Streaming is also part of it, but a long time ago we discussed by the CTO of Data-Minded. He gave the Data-Minded manifesto on data engineering, and one of them was something like batch is easy, streaming is hard, focus on batch first. Many of the pipelines that people write are batch pipelines anyway. Once you've written something and are able to schedule this on a daily basis, you need to have some notion about some orchestrators at some moment. We haven't even mentioned that here. In the summer school, we mentioned Airflow, but there are variants on that, like alternatives, if you really want to know them. Some of them are baked into products. For example, if I'm not mistaken, DBT has a scheduler built in. DBT Cloud, if I'm not mistaken, not Cloud. DBT Cloud has it as part of their offering. Jelena, you will know that one better because I'm not that familiar with
the core doesn't have it.
Indeed. So the concept is again the same, right? You want to run tasks at a certain schedule. And if you can focus and understand, okay, this is an orchestrator, this is not something that really crunches my data, that helps. Getting your code running over there means you also need to know a little bit about CI/CD. So it brings you back to that knowledge, like, okay, how do I know CI/CD? There are, again, many tools nowadays. You definitely need to know a little bit about YAML, but Bash helps a lot because most of the pipelines that the CI/CD tools run are, in fact, just simple scripts. And oftentimes they run on a Linux environment, which is then probably going to be a Bash shell for you. So we're coming closer to the end of our webinar, so I need to make sure I pay attention to the clock. I'm also going to ask already to the people, because we have a couple of minutes left, if there are still a few more questions that you really want to see a specific answer to, you can already start sending those out. But as I'm summarizing a little bit what Cedric, Jelena, and me have been discussing about, it's, yes, our world is changing, and there are many new products coming up. There are plenty of places where we can learn about them. Meetups, data science, Databeers, for example, Brussels is also one of those, in my opinion, one of those meetups, conference basically, where you can learn about it. It's not as big as a 5-day conference. It's an evening where you sit together with some people and drink a beer over some technology. So there are plenty of places where we can learn about them. But all in all, the concepts that they portray are not that unknown before, right? Things are always going to stay the same. So if you can focus just on that transferable piece of knowledge that you have, which parts of the entire software in development lifecycle as a data engineer do I need to know? How do I get my code into production? It's probably the most important piece. As Jelena also said it, make it work, make it fast, make it pretty. These things don't change. Even if tomorrow I decide I don't want to become a data engineer anymore, I want to go something completely different things, maybe hardware engineering or something, and I would still want to write code for that, I still need to understand these things. How do I get my product, my code, into one of those hardware chips? And how do I make sure that maintenance of those things becomes easy? I'm going to take a quick look here at the chat for a moment, and maybe, Jelena, you still want to add a few more notes to what I said for my summary here.
I would just like to summarize with so this is not all just fluffy talk, but like give some concrete examples to people, like where do we learn? A lot of platforms out there. I really like Coursera. Udemy is quite good. What I like about them, that courses are there to teach you how do things actually work, teach you about logic, not just making you memorize syntax. Memorizing syntax is not going to make you better data engineer. What is going to make you better data engineer is understanding how this technology work and how to quickly find the syntax, okay? Because syntax will also change. So you need to know how to work it. Medium is a very good source for different kind of blogs. Subscribe to that, read what's going on there. And technology-wise, just make sure you know the basics. Python, make it run, make it clean, make it fast, make it clean. And Git, because you can't work with other people without Git. Bash, cloud, learn any cloud. The others are going to be there. AWS is a good option, but if you know you're going to work with Azure, go for Azure. and so on. Maybe you can add, but I got the question. I think it's just for me, so I don't know if you see it. So maybe I can
see it. I'll answer it.
Yeah.
I'll try to in any case. Also to wrap up. I'm going to try to answer the ones that I'm seeing all of them here. First of all, on the public ones, Wouter asked us what the favorite cloud platform is of ours, Azure, AWS, GCP, or any of the less well-known ones here. Everybody has their own choice. I'm not going to give you mine, but there, again, it's about concepts, right? Giving you an example, AWS has a service. For example, it's... give me a second. I always have a moment with the names. I think it's EKS, Elastic Kubernetes Service. And under Azure, it's called AKS. Same concept. It's Kubernetes, just rebranded and a little bit of extra. GCP also has that. Actually, Kubernetes came from Google, so they obviously are going to have their own product there. It doesn't really matter for us so much which is our favorite cloud, as long as you know the concepts that make it click. What piece of technology do I need to solve this problem? Do I need some kind of a serverless compute for short times? Like, you can do lots of things at scale. Yeah, then maybe AWS Lambda or Azure Functions, for example. Again, same concept, different cloud, different name. Tainara, I hope I pronounced your name correctly. You were asking about something you read recently. A software engineer can be a data engineer, but a data engineer cannot be a software engineering. Well, our stake is on that one. I see some people smiling here. Jelena, go for it.
Okay, so I hear this a lot, and I can't disagree more. So being a good data engineer should also be good software engineer, but there is a huge part, and some software engineers who became data engineers don't realize that, and that's data. Understanding data is very, very important to be data engineer, and this is not part of your software engineering. There are, I think if you want to be good data engineer, you should master software engineering skills, but there is extra to that, and you need to learn this. So.
Mm-hmm. You definitely need to look at the data and inspect it more often, because it's not as clear cut. When, for example, if I would be writing an interface, a visual program, for example, yeah, then I know what I kind of want. I do want feedback from my users. Maybe I need to add a few more buttons. So there is the user experience part to that as well. But as a data engineer, you are dealing with data. You need to understand what is coming in. And even though people will tell you like, oh yeah, we've got clean data. Come on, we all know that. It's not always clean data. We learn a lot by just playing around and really seeing what are we really getting in here? What is in there? We need to do a lot of analysis work as well. Maybe a question, and the last one that I see here, I think that was the private question that was asked. Why do I need to know SQL with Snowflake and the NoSQL options out there? That is a very interesting one. First of all, SQL, why do you want to know it? Because it is really the lingua franca. Everybody speaks it. Everybody can understand it. Even Spark is kind of built on top of it. Actually, it is built on top of it. You need to know it. Under the hood, it talks SQL. If you can understand the query plan, you will know what is going to be executed. Coming back to the NoSQL options, so that's more for the, I forgot the term for this one. These are the non-relational databases that are designed for a specific purpose. Most cases that you will come across are served just fine with a relational database. And when you need a non-relational database, like a document store, for example, it's because you have something really specific in mind. Do you need to know it to become the best one? I would say no. It's good that you know that they exist, and kind of like the really big different non-relational databases that are out there. If you can summarize them in a few words, teaching is a way, by the way, to learn skills. This is why I'm happy that Jelena and Cedric are here. Teaching is a way to learn these skills. If you can talk to your buddy in the street a little bit like, oh yeah, I've done something cool with a non-relational database or something like that, and you know why you're using it very specifically, then you're good to go. Do you need to know all the ins and outs of that thing before you start? No, because then you're going to waste some time. It's good for your manager that you know of some of these things, but if you're not going to be using them in the next 3-4 months, well, our world is in constant change. Some of the things you might have learned about are going to be improved. I've definitely seen this with Airflow, for example, as a technology, going from version 1 to version 2, many improvements. But the core concept still stayed the same. It's a scheduler. So if you want to know more about non-relational databases, I would wait until you get a project where you really need to start working with it. But try to keep the categories aside. Why would I want to use this kind of non-relational database over this one? That would definitely help. All right. There are more questions coming in. No, perfect. I think we've got them all. And we are a little bit over time. We apologize for that. For the people who are still here, thank you for being with us in any case. We'll try to send you the recap of this in slides and some other thank you notes. And I think there's also a link to the YouTube video because I think it's going to be streamed there. That should be in your mailbox in about an hour. Thank you everyone for being here. I hope you learned something new. Bye.
Bye.
Bye, guys.